So, hello everyone. I'm Evelina Gabasova, and today I'll be talking about a little detective story that I call the mysterious correlation. So first, I work as a data scientist in the Alan Turing Institute in London, which is the British National Institute for Data Science and Artificial Intelligence. But this is some work I've done before actually joining there. So my boss insisted on mentioning that. So, about a year ago, almost exactly 1 year ago, there was an article. Developers who use spaces make more money than those who use tabs. And this was from the StackOverflow data blog. And they do developer survey every year. And this was using data from the developer survey. And everyone was like, oh, developers who use spaces make more money? What's happening there? And this is the main finding from that blog post, that salary for developers who use tabs and spaces is higher across all experience levels. So here on the x-axis, there's the number of years someone has coded as part of their job. On the y-axis is the median annual salary. And the red line are the developers who use spaces. And you can see that their salaries are overall higher everywhere. And people who use tabs, or both, they are sort of a bit lower also across the board. So everyone got thinking, so what's happening there? And even mainstream media picked that up. And they ran articles like, oh, programmers who use spaces in their code get paid more than those who use tabs. Amazing. Even BBC, programmers who use spaces are paid more. I don't know what the quotation marks mean here. Paid more. And then Hacker News came in and everyone was like, correlation is not causation. That's the sort of thing that everyone learns in their undergrad statistics classes, or even earlier probably, or just from experience. Correlation is not causation. But the thing is, the data are showing that people who use spaces are paid more. So what's actually happening there? So correlation and causation are two fun little things. Correlation only tells us that two things are related, that they behave in a similar way. For example, the World Cup is starting right now, and if a team wins, you see that country celebrating. That these two things are correlated. When a country is celebrating in the streets, that means their team probably won. But if someone starts celebrating, that doesn't force the team to win. So these two things are only related. And but the thing is, they also indicate that there is some relation between these two things. It's not just that one thing appears at the random time and the other as well. And if there is no correlation, that's a strong indication that there is no causal relation. But on the other hand, if there is a correlation, we can't actually say anything. Or can we? Well, I will look into that a bit more today. The thing is, everyone loves a nice correlation. Everyone. And the newspapers above all. I did just some random search, and for example, too much exercise can kill you, especially if you are a white man. If you do 7.5 hours a week of fitness, that doubles your risk of heart disease. And you can see that there is something suspicious going on here already, because they say, especially if you are a white man. That means someone ran some model, and they found that for this specific subgroup of people, something probably happens by chance or due to some other factors. Or chocolate may help keep people slim. Yay! Or is it maybe that people who report eating chocolate don't feel guilty about it because they are already slim, so they report that they are eating chocolate? Well, no, chocolate may help keep people slim. Or going to university increases your risk of getting a brain tumor. So if you never went to the university, you should feel happy, because this apparently happens. And happiness is a plate full of vegetables. Study finds that eating your greens can help improve your outlook on life. So next time you are really sad, just eat some broccoli. And this is not just the domain of tabloid newspapers. This is an article from 1976 where the author noticed that when the crime rate is high, the prisons are full. So he suggested that they should just release the prisoners to decrease the crime rate. And this is serious research. And the thing is, the correlation and causation, they are hard to distinguish. And the problem is that we don't really have the language to talk about causal relations compared to correlations. And when there is a correlation, everyone sort of just resorts to causation as a language. So this is quite a big problem, and I don't really see tabloids running things like the weight is associated with eating chocolate, because that doesn't help bring people in. So what with our problem with tabs and spaces? If you force your employees to use spaces, will you have to pay them more? Or if you want to get paid more, should you just switch to spaces if you are using tabs? That probably doesn't feel right. And the thing is, the standard things to check if you see a message like this. The first thing is it just a correlation? In this case, I'm inclined to say that it's probably just a correlation. What's the sample size? Did we get the results just by chance? Or is there some hidden cause that's causing the effect? So let's look at the sample size. This is a table of number of people who use spaces, tabs, or who reported using both, compared to their experience level. And yeah, the numbers, you just have to look at the numbers. But the best way to actually look at it is using a heat map, because then you can immediately see where the data are. And in this case, most junior people report using tabs. So that might be also an effect that if you haven't been programming for long, you just press the tab key and don't realize that the editor puts in spaces. Who knows? That also tells us that there are probably not that many more senior people reporting in this study, so that might be some effect with small numbers as well. But overall, we had quite a lot of people. These are in thousands. So that should be probably fine, and small sample size is probably not the main problem here. So did we get the results by chance? Well, in general, the larger the effect you observe, the smaller the sample size you need to actually get statistical significance. So if you observe just a very small effect, you need a lot of people. But in this case, the difference was basically something like $10,000 a year. So that's quite a big difference. So that's probably not a chance here either. And we observe the same result across all the experience levels. So this is probably fine. So is there some hidden cause that would be causing both of these things, to increase the salary and force people to use spaces? Well, let me tell you a story about storks. So do storks deliver babies? Well, there are these stories, what you tell children when they ask, so how did I came to be? And you say, well, storks deliver babies. There are these stories across all the different countries. So this is my theory. So storks deliver babies. What can I do? How can I test this hypothesis? Well, of course, I can look at the number of storks in a country and how many children are born there. And turns out if I do that, I get a correlation coefficient of 0.6 with p-value that's very low. So that means, based on this, well, this seems to indicate that storks deliver babies. These things are statistically significant and they are highly correlated. What's happening there? Does anyone have a guess? Well, should I just infer this? Well, probably not. And as I said, this is about hidden causes. So what if there is some hidden factor that influences both storks and babies? And if I remove this factor, then that seems that these two things are related. But if I add it into my model, then suddenly they are just related to the other cause. Well, turns out this hidden cause is the size of the country. So if I look at the size of a country and number of stork pairs, that's highly correlated, because the larger a country, the more storks there probably are. And if I do the same with children, well, the larger the country, the more children are born per year. So I have my hidden cause. This was fairly easy. So the country area influences both of these things. So the problem with correlation and causation, here I could tell that probably storks don't deliver babies. I have a baby, and stork didn't just randomly come out into the window and deliver her. So I knew that there is something else happening. But if I don't know that, basically the only way to get causation directly and be really sure of it is to do a randomized experiment, or something like A/B testing. So should we just go to college and take a bunch of beginner programmers and tell them, so you will use spaces, you will use tabs, you will use both, and then measure their salaries 10 years on? Well, we could do that. Probably no one will fund this kind of research. But there is hope as well. There are some ways to actually distinguish correlation and causation from observational data. It's called do calculus. It's quite a niche area in mathematics. But we need a lot of assumptions to do that. We need to know all the possible confounders that come into play. That means all the variables in the model, which probably for our tabs and spaces problem we don't have, because we don't know what are all the things that influence if a person uses tabs or spaces. And they are definitely not in the developer survey conducted by StackOverflow. And we need to have the right model. We have to assume some structure to the model. So that's the thing I had here. Sort of assumed there is one variable that influences directly both storks and babies. So we need to know the structure of the problem, and we need to know all the variables. And then there are mathematical ways to distinguish if things are actually causally related or not. But I can't do that here, because I don't know all the variables. So I can only assume that there is something that influences both tabs and spaces. And this little detective story is about how to find these things. So back to the StackOverflow model that I was showing you. And in the blog post, the original author did some linear regression trying to predict the salary. And he put in a lot of different things, like the country, because different countries have different salaries, years of programming experience, if people use tabs or spaces, what language people use, what's their level of education, if they contribute to open source, if they program as a hobby, and what's their company size. Assuming that all these things influence the salary. So we just stick this into a linear regression. And most of the times when someone tells you that they are doing AI, they are just doing linear regression. So that's exactly what we are doing here. And turns out most of these things were significant. But I thought, OK, so what if I remove tabs or spaces? Does the performance of the linear regression suffer or not? Because if it suffers a lot, that means this information is really crucial. But if the model can substitute the information from somewhere else, that means the information is just something that indicates something else that's in there. So, and sorry, I will go into a bit more statistics and mathematics. So we can actually compare models analytically in statistics if they are nested. So the full model will be the one with all the variables, and then I have something I call the reduced model, which is the one where I just remove tabs and spaces. So how do they compare? And now a bit more statistics. We can compare models, or linear regression models, using the R squared, which is basically it's the coefficient of determination that just tells you how much variance in the data does the model explain. And the full model explains, it's better to look at the adjusted one, basically 39% of the variance in salaries. So given all the information about tabs and spaces, company size, programming as a hobby, education, language, country, I can explain about 40% of variance in salaries. And if I remove tabs and spaces, I can also explain 39% of the variance. So these two values are basically the same. That means the information on tabs and spaces is nothing crucial that's not included in all the other variables in the model. So my first observation is it's probably not tabs and spaces that increase salary. So is there something called collinearity? That means two variables that behave exactly in the same way. For example, if I look at the weight and height of people, these two things are collinear because they change in a very similar way. And turns out there was nothing like that. I checked, there was nothing else that would just directly be the same as tabs and spaces. So what changed in the reduced model? So there were three things that were more significant, that increased in statistical significance. So the first one was years of programming experience. That's kind of what I would expect. The more senior you are, the higher the salary. Contributing to open source. Now this is more interesting. And the third thing that sort of I assumed was mostly by chance was PHP. So the thing I decided to look more into was open source, not PHP. Sorry if you use PHP. So what does open source and contributing to open source do in this kind of model? Well, if I just plotted, again, the number of years someone programmed against their salary and separated that based on open source contributions, turns out people who do contribute to open source, that's the orange line, have higher salaries than people who don't contribute to open source. So this is very good news for people who do open source and are very trained maintainers, probably. They should be paid more, or at least they are if they work in a company. So now we have something that's sort of related to tabs and spaces and increases the salary. So how does it actually look? How many people actually do use spaces and tabs in open source? Turns out people who do open source use spaces much more than tabs. These are two histograms or bar plots. So people who use open source, these are on the right. The blue ones, they use spaces. On the left, they don't contribute to open source, and they use tabs much more. They use tabs and spaces about the same. And this is for US developers. This is for all developers internationally. And even more people use tabs if they don't contribute to open source. So that's interesting. That seems that spaces are definitely associated with open source. And I think we might have some potential explanation here, because if you use tabs, they are, and depending on your editor and on your settings, they are visualized differently in the code. But if you use spaces, they look the same across editors. So if you just put your code into Git or GitHub, then you probably don't want them to look the same. So you would use spaces. So that's one potential explanation. But does it really increase the salary if you contribute to open source and use spaces? Or is there something else as well? But there might be the language effect. For example, people who report that they are using C#, they report more frequently that they are using tabs. Interesting. What about something like Python? People who use Python report that they are using spaces more. And let's look at, for example, F#. I use F# quite often. So, and in F# you can't use tabs, actually. So, and F#, yeah, most people report using spaces. And by the way, I have all these slides online, and you can play with them, because it's all literate programming, so you can edit everything and you get the graphs directly. What if I look at something like Ruby? yeah, more people report spaces. So turns out C#, maybe C# is associated with lower salaries. Sorry, I just see John Skeet over there. So there is definitely some language effect, but it's probably not associated with salary. But there might be some association with languages and open source, because some languages are just more common in open source. So right now we have several factors that sort of don't explain anything by themselves, but we have some language effects, some open source effects, some indentation. And what if we look at the indentation and contribution to open source and salaries together? Sorry, it's getting complicated. So let's make this a bit bigger. So right now, I just plotted what indentation people use, what's their salary, what's their experience level, and if they contribute or don't contribute to open source. So the darker colors are for people who do contribute to open source, the lighter colors are for people who don't. And the interesting thing is that right now, people who do contribute to open source and use tabs and are senior, sorry, a lot of conditions, that's here in the corner, suddenly they report higher median salary than people who use spaces. So that's slightly breaking the indentation method versus salary relationship. So that probably really does have some kind of effect. But overall, people who use spaces, that's the blue line, most of the time they are paid more than all the others. So still, spaces are associated with higher salary, even if I take into effect the open source contributions. So I decided to look at what's actually happening there. How does the data look from a different perspective? So I looked at salary distribution. This is for junior developers, but it looked the same for all the different levels of experience. And this is a density histogram, or smooth density of salaries. So the interesting thing here that the tabs and using both, they have just one main bump here. That means the salaries are distributed around this value and they are sort of nice, almost Gaussian shade. But people who use spaces, there is something else happening because there is one bump here. So most of the people who use spaces are paid the same as people who use tabs and both. So that's kind of reassuring. But then there is this huge group of people who are just paid more. And that group of people appears mostly only among those that use spaces. So, what's happening there? How can I find out what's happening in the group of people who use spaces and are paid more? Well, I can do some more statistical testing. So, sorry, this talk contains a lot of statistics. I got feedback on one of my talks that the talk didn't contain any machine learning and was just about statistics. So this one is more about statistics, though. So I looked at what distinguishes the people who use spaces and are paid more than the people who use spaces and are paid less. And turns out the thing that came out as the most different thing was the version control system. So now I'm like, oh, that's interesting. You can see that the numbers are quite low, so take this with a grain of salt. But it seems that among the higher salary people, Git was much more common than all the other methods. I did some proper statistical testing. You can actually see if it's significant or not using the Pearson's chi-square test. And the p-value came out really, really small. So it probably is significant, even though the numbers are small. So is this the version control that just distinguishes people who use tabs and spaces and people who get paid more or not? Well, let's look at some plots. So if you use Git, you are paid more than if you use TFS, Team Foundation Server. And this is just for US developers. So this appears to hold, again, across the board. So should you use Git? And you can actually use Git inside TFS. So I'm not sure how that compares. So what if we separate it by the tabs and spaces? So right now, the darker colors are people who use Git. The lighter colors are people who use TFS. And again, blue are spaces, orange are tabs, and green are both. So here you can see that actually the lighter colors are concentrated in the higher spectrum. That seems that really the version control system changes how much you are paid. So for example, here even among junior developers, people who use tabs and Git are paid more than people who use spaces and TFS. So the indentation and version control, they seem to be correlated as well, but the version control breaks the dependence on the salary. So what does this actually mean? And one interesting thing, people who use spaces and Git are paid more, again, but people who use spaces and TFS are among the lowest here. So should you just switch to Git everywhere? That probably doesn't work either. This is internationally. Internationally, the effect is not that strong, because it turns out that among junior developers, people who use TFS and spaces are paid more than all the others, which is different. But I will talk about this data a bit more later on. Internationally, subversion is more common than TFS. It turns out this effect holds even for subversion a little. The dark colors are, again, people who use Git. The lighter colors are people who use subversion. And it turns out that, for example, among senior developers, you can use tabs and Git, and you get paid more. You get paid the same as if you are using spaces. So, yay, version control. Let's all switch to Git, and our salary will increase. I will tell that to my boss, and let's see what he thinks. So why is version control so important? Well, my guess is that it's not actually open source itself or version control itself. I think it's the company type. Because you saw that most of the companies actually, where do I have my histogram? Most of the people who use spaces are paid the same as people who use tabs or spaces, tabs or both. And it's just this group of people who get paid more when they are using spaces. And that is associated with version control, open source, and various other factors as well. And I think this just points to a sort of company type. So if you are in a sort of old school company that basically doesn't rely on open source, that relies mostly on big corporate solutions like TFS, then you will probably get paid less. And if you are in a sort of new, cool company that gets a lot of venture funding, then you get paid more. And you use more open source, probably. And you probably use spaces, because spaces are more associated with open source. And you use Git because you use GitHub. So my assumption is that it's the company type. But that's not a variable in the model. So I can only come up with certain factors that are sort of related or that indicate a company type. But I can't observe this directly. So I can't really verify that mathematically, because as I said, I can verify things mathematically only if I have all the variables. And this is sort of a vague concept. But yeah, as I said, you can go to my GitHub and look at the talk and play with the actual numbers. But this is not the whole story, actually. Can we even trust the data? Because these data come from an online survey where people, just when they are bored at work, they just fill in some random numbers. And most of the stuff I was showing you was on US developers. And I will tell you why. I looked at the data, and I looked at the salary distribution itself. And this is the histogram of salaries across all the countries, across all the respondents. And you can see that there is something weird. What's this thing in the beginning here? That's people who report very low salaries. So I looked at people who report their annual salary lower than $3,000. That's not much. That's $250 per month. So this salary is most common in India. So sort of, yeah, India, you kind of expect very low salaries, unfortunately. But the second one was Poland. Poland is a European country. Our people in Poland paid $250 per month when they are programmers. Well, yeah, my Polish friends over there are saying no. The second one was Russia, then Brazil, Romania, Pakistan, Ukraine, and Germany. Our people in Germany paid $250 per month when they are developers. I don't think so. So what's happening there? Well, this is the salary distribution for people from France, India, United Kingdom, the sort of normally behaving countries. And you can see that they are nicely distributed. They have just one bump. So that's the salary distribution. What if I look at Poland, Germany, or Russia? You can see immediately that the distributions look different. There is something strange happening there. They have one more bump in the beginning. So for Germany, the blue one, the bump is relatively small. For Poland, it's bigger. And for Russia, it's even bigger than the main bump. I don't think people in Russia are paid $250 per month, like most of the people in Russia, per year, sorry. So what's wrong? What's happening there? Well, this was the question that was in the online survey. What is your current annual salary in currency, blah, blah, blah. Please enter a whole number in the box below without any punctuation. If you prefer not to answer, please leave the box empty. Annual was underlined. But do you think that people actually read questions online properly? They just looked at it, thought, salary. Yes, this is my salary. And the thing is, I'm from Czechia, so I have a bit of background knowledge. Everyone, whenever they negotiate their salary, talk about their salary, they always talk about their monthly salary. No one ever mentions their annual salary. That's just not how things are discussed. So I thought, okay, people just saw salary, wrote in their monthly salary. Let's verify that. Well, this is the distribution for Poland. I fitted two distributions to that, and turns out the lower one, the small one, is roughly 1/12 of the big one. So I even fitted a more complicated model, and turns out about 25% of people in Poland don't read questions properly. And even more people in Russia. But even very, very precise Germans still don't read questions properly. So this is when I adjusted the salary, and it looks much more reasonable when I basically just multiplied the smaller bump by 12. You can see that it looks much more reasonable. So there were more countries like that. So I basically decided that I can't trust this data, really. And the other thing is that quite a lot of the data were missing. Basically, most of the people didn't really report their salary. So why did people not fill in their salary? Well, the first factor might be they just got bored with their survey and finished early. The other thing, they just didn't want to compute that because they just know their monthly salary and were not bored enough to multiply that by 12 and fill it in. Or they didn't even mention if it's before tax or after tax, because in some countries people actually discuss their salary after tax, which is much more telling. So the thing is, with missing data, it's a bit more complicated. In statistics, there are different categories of missing data. Because if you have a survey like this, data can be missing completely at random, or just at random, or not at random. What does it mean? Well, data missing completely at random is basically a dog coming in and chewing half of the data. The process that generates the missing data doesn't depend on the data at all. Or you lose half of the survey, you lose half of the data, or just, basically a dog coming in and chewing half of it. Data missing at random, it says at random, but it's not really at random, because well, for example, my colleague was looking at some data from Weight Watchers online reporting service, something like that, where people who are trying to lose weight report how much they eat, what they eat, and how much they weigh. And turns out people basically sometimes stop reporting their weight. And you can determine which people will stop report their weight based on their previous weight and what they are reporting that they are eating. They stop reporting their weight the moment they stop losing it. So they basically don't want to admit even to the online system they are failing in their weight loss. So they stop reporting that. So data missing at random means that you can infer which data will be missing from all the other data that you have. So this is not something that we would normally call at random, but in statistics that's called at random. And missing not at random means that the data that are missing is related to the data that are actually missing. So you basically don't know why they are missing, but they are missing, and it's related to the question. So for example, well, if someone was just walking around and asking people, do you have any sexually transmitted disease? A lot of people wouldn't answer, but there you can actually infer which people won't answer, because that's probably the people who have something, because they don't want to admit it to a person in life. But missing not at random means you don't know why the data are missing, and it's related to the question. And the thing is with salaries, the data that are missing are usually missing at random or not at random. Sorry, this sounds stupid if you read it as a normal English, but these are statistical terms. So data on salaries are, when they are missing at random, you can usually say that people who work in like state-owned companies, state-run companies, they don't really like to report their salaries because they are usually lower than like cool, hip companies, and they know that, so they are a bit sort of, yeah, my salary is quite low, I won't report that. And missing not at random, people who have high salary, they usually don't like to report it either. And more so when you ask someone in person. And in a lot of countries, that's sort of a taboo question. How much do you earn? Oh, mind your own business. People won't admit how much they earn, and usually you can't infer that from the rest of the survey. So the data are missing at random or missing not at random. So these two things that are definitely there in place, so they definitely affect at least the tails of the distribution, how it behaves on the extremes. But as I said, some people reported wrong values because they didn't read the question properly. So the first data trap were wrong data, and the second one were missing data. And sometimes people even report wrong numbers. I looked at it, and the survey even included quite a lot of people who reported 0 as their salary. And these were just professional developers, so maybe they are just consulting right now and they are not paid anything or like having a break. And the thing is, data can be wrong or missing either accidentally or deliberately. And this happens quite a lot, actually. For example, if you are doing surveys on like who are people going to vote for, the estimates for Donald Trump in presidential elections were underestimating what he actually got. And one assumption is that people just were ashamed to admit that they are going to vote for Trump. And this happened even before. This is from 1989, mayoral elections in New York, where one of the candidates was black and the other candidate was white. And basically, the polls were wrong by 20%, because the assumption is that white voters were sort of reporting they'll be voting for the black candidate, because that was sort of the better option, or they just wanted to be seen as more open and more colorblind. So the polls were completely wrong. And this happens a lot. So the first thing is, can you really trust the data? And usually with online surveys, usually you can't really. So when you are discussing if you should be using the tabs or spaces, yeah, maybe just don't trust online surveys. And right now, a lot of machine learning, most machine learning methods, there's this push of using them as a black box, basically just putting in data and looking at the results without actually going through the internals and how does it work, why did it reach this conclusion. And I think it's quite dangerous, actually, and there should be better tools for interpreting data. Because right now, I just put the data into a model, it spit out that people using tabs have lower salaries than people using spaces. And if I didn't understand the domain, I would end up the same way as the guy writing the paper about crime rate and people in prisons. When the crime rate is high, we should just release people from prisons to lower the crime rate. I think it's not that simple, and if we don't really understand the domain, it's really hard to distinguish if things are correlated or if they are causally related. So, yeah, as I said, machine learning as a service, don't take it as a black box. Think about the results. And the thing is, right now, most of machine learning is about correlations. It's just about learning by associations. With supervised learning, you give an algorithm some input and some target outputs, and you train it on this mapping to predict the target based on your inputs. And that's just teaching it the association of inputs with the outputs. It doesn't know anything about their relations. And Judah Perl, the founder of the do calculus for inferring causality, did an interview like a month ago or 2 months ago, and he said that as much as I look into what's being done with deep learning, I see they're all stuck there on the level of associations, just curve fitting. And this upset a lot of people, because they thought, okay, this is not just curve fitting, we are doing this real cool thing, we are doing autonomous vehicles, we are doing speech recognition. It's still just curve fitting. And it's just learning associations that are too hard for us to just learn directly, but for the machine, it's just curve fitting, fitting numbers to numbers. And the machines just don't know anything about causality. So if we just take the models as they are and not think about what they are actually doing, then we'll get into this trap as well. And we probably won't get anywhere with artificial intelligence and killer robots and things like that, unless we do something with causality. Because the machines just really don't know. So the main message of this talk is that if you see some fun correlation, just saying that correlation is not causation is not enough. There are more things you can do, and this is just a mantra that everyone learns, but it's not the whole story, because the association is really there. So there is something that's causing that, and it's possible to identify that. This was sort of my aim of doing a little detective story, how I went on such an investigation. Usually you don't have the data available. I should thank the StackOverflow data team, because they actually made all the data available. So it was possible to do this, and they even made all the code that they used for their analysis available, so I could just come in and tweak things and play with them. And you can go and play with this talk as well. And I think this is really good to give just people the tools to do that, the methods, and then you can see what's actually happening there. And yeah, as I said, the main problem here were the data. And all the analysis that I was showing you, you should take it with a grain of salt, because the sample sizes got very small, because I basically discarded all the people that I wasn't sure were reporting their annual salary. And I was looking at only US developers and only the ones that reported using Git or TFS or something else. So the numbers got really small, but I believe that they are at least pointing somewhere. But unfortunately, all the data are not in the survey. And that's usually the question, because the problem, because we can't fit the whole world into a statistical survey. So this was, sometimes at work we joke when we get data from a client that we spent first 2 months just investigating what's actually happening in the data. So we should be called not data scientists, but data detectives. So this was my attempt of being a little consulting data detective. And if you have any questions, just ask me, see me around, or ping me on Twitter. And you should be able to find this whole talk on my GitHub. And thank you. And use spaces just to be sure. I think also one effect is that people really press the tab key, and it wasn't really certain what the survey is asking about. Do you press the tab key or do you press the space key? So I think that's an effect there as well. Right. Thank you.